Okay, graph the rational expression. It's a rational function when you have one of your independent or y is a dependent variable, x is the independent variable. If that's in the denominator, it's a rational function. Okay. Now there's three things when we graph we need to know about rational functions. We need to know the horizontal asymptote. Put HA. That stands for horizontal asymptote. Okay, that's a line you can't cross that goes this way. There's also going to be vertical asymptote. Those are lines that go this way. And then we're going to have to check for something that's known as holes. Okay, so that we do the horizontal asymptote first, get that out of the way because it's easy. You write y equals, and then you set the first term in each numerator denominator on top of one another. You ignore the rest of them, you just put x second over x. Now, simplify that. So x second, x first. You take out the smaller x minus 1 from the top, and it's x to the first. Now, where's x at, top or bottom? It's on top. So if it's on top, there is going to be none for the horizontal asymptote. So no horizontal asymptote. Okay? Now, had I ended up with x on the bottom, it would be 0. Okay. Now the vertical asymptote, that's a little bit more work. Okay. You got to see if you can factor each of your expressions. So I have two terms on top, two terms on bottom. Okay. I want to see if I can factor those. So on top I have x second minus 4. Well, that's two terms, so that would be GCF. Which would be 1, and then a difference of perfect squares. That's two terms. Okay, so I have a minus. You don't need the 1. X seconds x times x. 4 is 2 times 2. So it's x 2, 2. So I didn't do a GCF, so I just end up with these two parentheses, x plus 2 times x minus 2. So I rewrite this as this, x plus 2x minus 2. Now how about the x plus 2 on bottom? That's two terms as well, so that would be GCF DOPS. Okay, 1 is your GCF, and it can't be a DOPS, so we didn't do anything with that. Take the 1 back off, and that stays the same. Now, here's how you find your vertical asymptote. You take the expression on the bottom, the factor you have, and set it equal to 0. Okay, so just go x plus 2 equals 0. Minus 2 minus 2. X equals negative 2. Now, before you draw that, okay, because we had none for that, before you draw an asymptote at negative 2, you need to see if you can cancel, and on this one you can, okay? So what did I just cross out of the bottom? X plus 2. Okay. So when I did x plus 2 equals 0 and got negative 2, that then is no longer an asymptote. It's a hole. Okay. Hole in the graph. X equals negative 2. So then vertical asymptotes, we don't have anything else, so that's a none. Okay. Now, we write our new expression when we canceled out, and it's x minus 2. Okay. You don't need to, you can put in parentheses if you want, but you don't really need to. Now, if there's no bottom, this is going to make a line, okay? That's all it does, okay? Easy. So line, y is by itself, we got m and b, mx plus b. So slope, y-intercept. It's kind of nice when you end up without a bottom. So slope's 1 over 1, negative 2 is the y-intercept. You don't do the whole until the end. You do the whole when you're done. That's the last thing you do. So on the y-axis, you go to negative 2. So we didn't end up with any asymptotes to draw. Then we go up 1 over 1, up 1 over 1, and make the line as straight as you can. Now here's what you do at the whole. You go to negative 2 on the x-axis, and you measure where that line's at. You circle that point, and you label it a hole. Okay? So that means there's like a little hole poked in the graph. Now the reason there's a hole poked in that specific point is because if x is negative 2, negative 2 plus 2 is 0. And you can't have a 0 in the denominator, because if you do, a 0 on bottom, because if you would take a number and divide it by 0, I just randomly picked a 9, I get domain error, okay? So x can be anything except the -2, okay? Because -2 plus 2 would be 0, and that would give me a 0 on the bottom. So you just circle that and put whole. Okay, next problem. Y equals 4x over x to the third minus 4x. So we recognize that that's a rational function. We have to do our horizontal asymptote, then the vertical asymptote, then any holes, if I'm able to cross out like I was on that problem after I factor. Okay? If you don't cross anything out after you factor, there will be no holes. Okay, so the horizontal asymptote, I take the only term I have, 4x, that first one's just a single term, over the x to the third. Okay, so x second, x third. Okay, well, x second goes away, x first goes away, I should say, minus 2, x second. So there's still an x there, but it's on bottom this time. So there will be an asymptote if x ends up on the bottom, okay, then y equals 0. And it could be x to any power. If that variable's on the bottom, then the horizontal asymptote is y equals 0. So, remember, that's a horizontal. It goes across. So you go to 0 on the y-axis here, and you make a line straight across. Now try to extend it past your axis so you don't get confused, so you see that that's there. Now label it y equals 0. Okay? You cannot cross that line. Now the vertical asymptote, so one that goes this way, you have to find that by factoring. Okay? Well, the top, that's only one term, so I just drop that. I'm not going to be able to factor one term, 4x. Now the bottom, there's two terms, so we need to see if we can factor the bottom. So I have 1x to the third minus 4x. So that's two terms, so it's GCF dots. Okay, so I have x on the end, negative in front, nope, 1x is the GCF, so I go up and divide by 1x, and I have 1x third divided by x, though, is a remainder of 2x's, x is second. So negative 4, then x divided by x is just a complete wipeout. So I bring down the 1x. Minus, you take the 1 off. Actually, you can take the 1 off the x there. At the end, I don't want 1's in front of the x's. So x times x, 2 times 2. So that's a dots. So x plus 2, x minus 2. So you're replacing this with x, parentheses x plus 2, parentheses x minus 2. Now, after that's done, now you go do your vertical asymptotes. So you have that outside x factor that could equal 0. So circle that, okay? X plus 2 could equal 0. That'd be negative 2. X minus 2 could equal 0. That's positive 2. Now we got to decide if any of those vertical asymptotes become holes, okay? Now you're not going to cross out any of your parentheses, but you see this outside x and this outside x? They're both to the first power, so they both wipe out, okay? So, see that x outside? The one I set equal to 0? Well, now that x equals 0 is now a hole in the graph, okay? Okay, instead of being a vertical asymptote, it becomes a hole. If it was canceled out, okay, that factor, the factor I used to get that asymptote, that is now a hole. Okay, so write your new one after you simplified it, okay? And now, after you find your holes, actually, after you identify, after you're done with all this crap down here, okay, you have to set up your vertical asymptote. See, on the last problem we had none, okay, because it ended up being a hole. But when we end up with the remaining vertical asymptotes, we need to plot those. So we go to negative 2 on the x-axis right here, and it's a vertical asymptote. Okay. Please label it above, x equals negative 2. Now x equals 2, right there. Okay, and that's also a vertical asymptote. So you have two vertical asymptotes, which makes this suck. This is as sucky a problem as it gets. Okay. Now, please write this in simplified form after the cross out. So you have 4, the parentheses x plus 2, the parentheses x minus 2. Okay. Now, when you have two vertical asymptotes, and there's two of them, okay, see if there's only one of them, you just go right, left. Now you have to go left, or it doesn't matter, left or right first. Left, right, middle. Okay, you're going to put 2 coordinates under each one. Now we got to do some math, okay? Now, left of what? Well, here's the left one on the left. Put x equals negative 2 here. Here's the one on the right. Put x equals 2. And the middle's between these two, okay? So, this is the left, this is the right asymptote. Now you're going to pick 2 points to the left of negative 2. Let's go negative 3, negative 4. And then 2 points to the right of positive 2. Let's go 3 and 4. And then 2 points in between those. Well, how about, I don't know, 0 and negative 1. Okay, now you got to put those into your simplified function right there. The simplified. Don't go to the top, go to your simplified one. Okay. So, what you're going to do is first make a line. We're going to put negative 3 in for both the x's. Now you have a 4 on top of the line. You don't plug anything in if it's just the one number. It's 4. Now you're going to substitute negative 3 in for each x. Okay? So parentheses negative 3 plus 2, parentheses negative 3 minus 2, and you put that underneath your 4. 5 is what I got. 4 divided by 5 is 0.8. Okay? So I put this negative 3 in for here is 4, then it ended up as a 5, so 4 divided by 5 is 0.8. Okay? Now I repeat the same process with negative 4. So I've got the 4 on top. The top is set. Okay? I just need to substitute negative 4 on the bottom. So negative 4 plus 2, negative 4 minus 2 is 12. Okay? 4 divided by 12 is 0.33. 0.33. So I put 0.33. Now I plot those points. So start in the middle. Negative 1, negative 2, negative 3, 0.8's here about. Negative 4, 0.33. So 1, 2, 3, 4, 0.33 is just closer to the 0. Now remember, you can't cross any of your asymptotes, whether they be vertical or horizontal. So I go against the vertical that way, and here I get closer to the horizontal. Okay, so that's just the left. Now we repeat the same process with the 3, okay, into this function here, this one here. So what's on top? Well, we have 4 again, okay. Now I take that 3 and substitute it in for each x. So 3 plus 2, 3 minus 2, 5. That's right, so that's 0.8. Who cares if it's the same thing? Just go with it. Now put your 4 in for x. Now you still got this 4 from the top. That's where I'm getting that 4 I keep putting on top. Divided by. Now I need to substitute 4 in for the x's. So 4 plus 2, 4 minus 2. And I got 12. Okay, 4 divided by 12 is going to be 0.33. Okay, I know that's only by accident. Don't let that mess. Oh, it's just the same thing. Well, no, it's not. So now you go to 3, 1, 2, 3, 0.8's right there. Okay, 4, 0.33, so here's the middle, 1, 2, 3, 4, and right there. So remember, you don't cross your asymptote, so essentially it does the same thing the other one did. Okay, now the middle. So you got y equals 4, so 4 I put 0 into the denominators for your x's. 0 plus 2, 0 minus 2. It's going to be 2 times negative 2, which is negative 4. So that equals negative 1. So 0, negative 1. And then I have 4 in the numerator. Now I put negative 1 in for the x's. Negative 1 plus 2, negative 1 minus 2, I get negative 3. Okay. So then 4 divided by negative 3 is negative 1.33. Okay, now plot those. 0, 1 is right there. Okay, negative 1, negative 1.33. Okay, negative 1, negative 1, 1.33 is there. Now what happens here is this forms, since there's a horizontal asymptote that we can't go, we go against the asymptote that way and then the other way. Okay. Now I do want you to remember that hole. The hole is x equals 0. Okay. So just find your 0, that'd be in the middle, and go find where you have a part of a graph, and that's your hole. Okay. Okay, next problem. Y equals x plus 4 over x minus 4. This one's a little bit more manageable. Okay. So, you've got your horizontal asymptote, your vertical asymptote, and your holes. Remember, the holes go off the vertical asymptote. Okay. Okay, so the horizontal asymptote, you just take the x over the x. Well, they're both to the first power, so that's a wipeout, which means it equals 1. It's not 0, it's 1. Okay, so y equals 1. So you got a 1 on your y-axis, okay, and you draw a horizontal asymptote across there, okay. Okay, then the vertical asymptote, well, we need to see if we can factor, okay, either expression. You got 2 terms in each, so x plus 4, that would be GCF, and dots. Okay, so GCS 1, you wouldn't do that, okay? Difference of perfect squares, no, it has a plus sign, so that one's staying the same. And then this one does the same thing, the GCS 1, it's a difference, but x isn't to the second power, so we know that one's not going to be either, okay? That's x plus 4, sorry, plus 4. So they both just stay the same. Now, find your vertical, you set that x minus 4 equal to 0, and you add 4 to both sides, and you get 4. Now, are you going to be canceling anything here? No, these two parentheses are not the same. Nothing can be canceled, so holes, there's none. Okay. Now, you got to set up your vertical asymptote at 4. That's x equals 4. Okay. So horizontal, you go to 4 on the x-axis, 4. And there it is. Okay, I also label these. Okay, this asymptote up here is y equals 1. This asymptote is x equals 4. So you only have one vertical asymptote, so it's just a right-left. You don't need that middle bull crap. Okay. Okay. So right-left to what? Well, it'll be right of the x. My x equals 4 is the only one I got, so that's what I go with. Okay. So. Okay, so right of 4, we'll go 5 and 6. Left of 4, you go 3 and 2. Okay. All right, now, got to substitute those in. Well, fraction, put in 5. 5 plus 4 is 9. Hope you wouldn't need a calculator for that. Now, bottom 5 minus 4 is 1. 9 divided by 1 is 9. Okay. Now, 6. 6 plus 4 is 10. And then 6 minus 4 is 2. So that equals 5. Okay, so 5, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So again, you can't cross it. You approach the vertical asymptote that way and the horizontal from the other way. Okay. Now, the other ones, okay? So, go back up here. So 3 plus 4 is 7, divided by 3 minus 4 is -1, so that's -7. So 3 -7, oh, first let's get the other 2 output. So put 2 in, 2 plus 4 is 6. 2 minus 4 is -2, and that's -3. Okay, so 3 -7, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay. 2, -3. 1, 2, 1, 2, 3. So they go against the asymptote. There's no holes, there was none. Okay. Okay, y equals x to the second power plus x over x plus 1. Okay, so you've got your horizontal asymptote. I do that first because it's easy. Then the vertical asymptote and any holes that we have, points of discontinuity. Okay, so horizontal asymptote, you just put your x second over your x. Now simplify it, get rid of your x to first minus 1, that's 1. Now is the x on top or bottom? It's on top, okay? So if it's on top, then there is no horizontal asymptote, none, okay? So no one's going across, nothing. Okay, now the vertical asymptote, let's talk about that, okay? Well, the vertical asymptote is when you have to factor, okay? To find what your x's couldn't be equal to. And that's the top and the bottom. So we have 2 terms on top and 2 on the bottom. So we need to see if they can both be factored. So 1x to the second plus 1x. So GCF DOPS. Okay, so x on the end, no -1 and 1's 1. Okay, but we got to divide by 1x now. So that's 1, that would be at remainder x plus 1 with no remainder. So you bring your 1x down here. That's not a DOP, so you write no, and you put 1x plus 1. Now take the 1's off the front of the x's, okay? So you're rewriting this as x and then x plus 1, just like that. Now about the bottom, 1x plus 1. It's 2 terms, GCF and DOPS. 1 is a GCF and it's not a DOPS, so that's in prime form, okay? So take the 1 off the front, you just rewrite, you're not rewriting it, it just stays the same. Put it in parentheses though. Now, vertical asymptote, you take the x plus 1, set it equal to 0. minus 1, you get -1. Now, is that going to stay an asymptote or does it become a hole? Well, let's see if that can cancel. Yes, it can. So then that x plus 1 is gone, so that -1 I got from the x plus 1 now is not a vertical asymptote, it is a hole. Okay? So I don't have, that's none for vertical asymptotes. You don't have any asymptotes. Okay? Now write your new function, y equals x. Well, now it's just a line, okay? When that bottom cancels out completely, it's a line where you don't have to do that right, left, middle crap, okay? And then plus 0 would be your b. So slope would be 1 over 1, y-intercept is 0. So 0, 1, 1, 1, 1. Make the line. Now you got to check for holes. We have a hole at -1, okay? -1, well, I don't have to go very far to get to my line. I make a point, circle it, and that's a hole. That's a point of discontinuity. Because if x is -1, -1 plus 1 is 0. Having a 0 on the bottom is bad. X cannot have you can't have a value for x that gives you 0 on the bottom, okay? It can be anything else, because anything else wouldn't give you 0, okay? But that's your hole. Okay, next one. Y equals x plus 6, that's a 6, both these are 6's, divided by x to the second minus x minus 6. Okay, so horizontal asymptote, vertical asymptote, and whole. Okay, so horizontal, you just put x over x to the second. Now the x first goes away, but where's x? Top or bottom? It's on bottom, so now it's the asymptote. There is an asymptote, and it is 0. Y equals 0. Let's go to 0, make the line going straight across. Okay, there you have it. Okay, y, that's how you do a horizontal asymptote. Again, x on the bottom, then the horizontal asymptote 0. Okay, if x is on the top, if x winds up on the top with no x on the bottom, then that's when there's none. Okay. Okay, vertical asymptote. You got to do the factoring to figure out what goes there. Okay. So top x plus 6. It's 2 terms, so it'd be GCF dops. So 1 for GCF. Can't be a dots, so that guess we have to keep it in its original form. This expression here, x to the second power minus x minus 6. So these are 1s, that's a trinomial, so GCFT. One is a GCF, and ABC, it's negative 6. That's a mismatch. So it's positive, negative. It's got to add to negative 1. 1 and 6, that's negative 5. 2 and 3, there's your negative 1. Okay? Your A is 1x to the second. So positive 2, negative 3. So x, put the 1's in front. Those don't divide. You can divide them by 1, and that's about it. Take the 1's out the front. You got x plus 2x minus 3. Okay, now you take the bottom factors, not the top, the bottom, and set that equal to 0, because remember, that's where we can't have x be 0, the bottom. I don't care if the top is. Minus 2, x equals negative 2, plus 3, x equals 3. Now, are either one of these going to become wholes? Okay, that's the question. Well, since I can't cancel either one of them, then no, there are no wholes. They'll stay asymptotes, so you got to label your asymptotes now. So you go to negative 2, and you make a vertical line. You go positive 3, and you make a vertical line. Please label those. And then this is pretty much the graph from hell. Okay, because you have 2 of them, you got to go left, right, and middle. 2 coordinates for each. Okay, I could make you do more, but this is already bad enough the way it is. Just put it under there. Okay, so left of what? Well, here's the asymptote on the left, negative 2. Right of what? 3. Middle. Don't know, middle is just in between the 2. So what's left of negative 2? It would be negative 3, negative 4. What's right of 3? 4 and 5. Okay. I would go at the first 2 numbers. Okay. Give me 2 numbers in the middle, negative 2 and 3. Well, heck, you can go 0. Let's go 0, 2. Okay. Okay, now top, bottom. So on top, we got x plus 6. We're going to substitute negative 3 for x. See, I'm taking the negative 3 and adding the 6. That's 3. Then I take negative 3 and substitute it for both x's on the bottom. Negative 3 goes here, but when I figure that out, then negative 3 goes in for these 2. Okay, 6. 3 divided by 6 is 0.5. Okay, divide them. That's how I'm getting the 0.5. 3 divided by 6. Okay. Now negative 4 goes in for all these x's. Let's figure out what comes out of the top. Negative 4 plus 6 is 2. And on the bottom, we got negative 4 plus 2 and negative 4 minus, negative 4 minus 3. Can't get it wrong. 14. 2 divided by 14. 0.14. So negative 3. 1, 2, 3, 0.5. 1, 2, 3, 4, right there. That's just closer in than 0.5. Remember, you can't cross any of the asymptotes, not the vertical and not the horizontal. Okay, now put 4 and 5. Okay, so 4 plus 6 is 10. So you go 4 plus 6 is 10. 4. Put 4 in here and here at the same time since you're on the bottom. 4 plus 2, 4 minus 3. Okay, I got 6. 10 divided by 6 is a decimal. It's going to be 1.67. I'll substitute the 5 in for x. So 5 plus 6 is 11. Okay, then I put the 5 here and here. So 5 plus 2, 5 minus 3, 14. Okay, so 11 divided by 14 is 0.79. Okay, so 4, 1, 2, 3, 4, 1, and then part way. 5, 0.79. 1, 2, 3, 4, 5, 0.79 is just between the 1, so we go this way. Okay. Okay, now the dreaded middle. Put 0 in for x. Guys, if I put a 0 in there, 0 plus 6 is 6. Now, this would be 0 plus 2, which is 2. 0 minus 3, which is negative 3. And it's negative 6. So that divides into negative 1. Okay. Now I put 2 in. Okay. So 2 plus 6 is 8. Now I put 2 in for the x's. So 2 plus 2, 2 minus 3, I got negative 4. 8 divided by negative 4 is negative 2. Okay, so 0, negative 1, that's a y-intercept there. And then 2, negative 2. Again, since these are on the same, remember this is asymptote, you can't cross the asymptote line, okay? Any of them. Not this one, not this one, not the middle. So essentially that's going to make a parabola. Okay, any holes? I think not, no.